All right, hi everybody. This is week 11, and this is the third video for week 11. This is the last video of the week. It's also the last video of chapter 12. So chapter 11 was first for OChem, now chapter 12, and then we're going to move to chapter 14 next week. All right, so the end of the last video, we had the first reaction for alcohols, and that was dehydration of alcohols to make alkenes. Now we have our second and third type of reaction. Both of these are oxidations. So number 2 is oxidation of primary alcohols, and they get oxidized all the way to the carboxylic acid. So in the example, I have a primary alcohol. It's 1-butanol, and it gets oxidized all the way to the corresponding carboxylic acid. So the carboxylic acid's name, which you do not know yet, you'll learn that in chapter 14 next week, it's butanoic acid. I'm just putting the name down so later on when you review for exam 3, you'll have the name. So the aldehyde, I put brackets around because it's an intermediate, and we don't stop there. The oxidation goes all the way across to the carboxylic acid. Second example, this would be what? 2-methyl-1-propanol. It's getting oxidized all the way to the corresponding carboxylic acid. So I've shown the carboxylic acid in condensed form right there. See how it has a COOH? You will see COOH quite a bit, and that represents a carboxylic acid in condensed form. I'm also drawing it out for you right now so you can see the carboxylic acid looks the exact same as it does in the first example. All right, you'll learn later why it's called 2-methyl-propanoic acid. You'll learn about carboxylic acids in chapter 14. The third and last type of reaction for alcohols is the oxidation of secondary alcohols, and secondary alcohols get oxidized to ketones. So the primary alcohols are oxidized to carboxylic acid. Secondary alcohol, like in this example at the top of page 2, they get oxidized to ketones. So 2-propanol yields, upon oxidation, 2-propanone, all right? And we'll learn how to name ketones later on in this video. 2-propanone will make sense later on in this video. Second example, I have a secondary alcohol, again, getting oxidized to a ketone, again. So this is 2-pentanol, getting oxidized to 2-pentanone, all right? So primary alcohols get oxidized to carboxylic acids. Secondary alcohols get oxidized to ketones. You note here, tertiary alcohols do not readily undergo oxidation. So for us, we would just write NR as products. NR means no reaction. So here is an example of a tertiary alcohol, and we would write NR for no reaction. The little O in brackets just means it's undergoing an oxidation. All right, now let's talk about aldehydes and ketones. Okay, alkanes are done, alkenes are done, alkynes are done, aromatic compounds are done, alcohols are done. Now we're focusing on aldehydes and ketones. So first of all, in general, the carbonyl group is a C double bond O, and then it varies on what the two attachments are to the carbon. The carbonyl group is a strongly polarized functional group because the oxygen is more electronegative than the carbon it's attached to. So you see me drawing the two partial charges, partial positive, partial negative. That's what the little delta thing means. That squiggly D is delta. And then I've got my dipole moment, right, where we're going in the direction of carbon towards the more electronegative oxygen. So that's a polar functional group. What is an aldehyde? An aldehyde is a carbon double bonded to an oxygen, and you have to have an H attached along with some other organic group, okay? So RCHO is how you would draw that condensed. Ketone, on the other hand, does not have its carbonyl carbon attached to any hydrogens. The carbonyl carbon is attached to 2 carbon-based organic group R, and it has the abbreviation RCO R prime. R prime could be the same as R. It just means they're not necessarily the same carbon attachments. Now, how do we name aldehydes and ketones? All right, well, the simplest ones have common names. Common names are things like acetaldehyde or acetone. But let's just start with the aldehydes first. So how do we name aldehydes? Well, we use the alkane kind of parent, and we attach the Al to the end of it. So one carbon is like methane, but it's methanal. Common name in parentheses, formaldehyde. So the IUPAC name is methanal, common name formaldehyde. Two carbons is kind of based off ethane. This is ethanol. It's an aldehyde, so it's got the Al ending. Common name acetaldehyde in parentheses. The third one I've drawn here as an example has a 1, 2, 3. It's a 4 carbons with one of the 5 carbons, but one of them is a branch. 3-methyl-butanal. That's the IUPAC name. Next example, the fourth example on this page. This is the common name is all I'm going to give you. That's why it's in parentheses. This is benzaldehyde. All right, so those were some aldehydes and how to name aldehydes. Ketones. How do we name ketones? Well, ketones get the ONE suffix, one. That's their ending. So this is 3 carbons. So it's some sort of propane derivative, and it's called 2-propanone because the 2 represents where the ketone is. Off of carbon 2. Common name for 2-propanones, acetone. Second example, 4-methyl-2-pentanone. So it's a lot like 4-methyl-2-pentane, but it's 4-methyl-2-pentanone, with the 2 representing where the ketone carbon is. So let's do some examples kind of mixed together, ketones and aldehydes. Draw structures of the following. So now I'm going to give you the names, and we've got to draw the structures other way around. A is hexanal, B methylpropyl ketone. So B is actually a common name, but hexanal is an IUPAC name, which is quote unquote official name, IUPAC. Hexanal, it's got 6 carbons, and aldehydes are always on the end because they have that little terminal H. Methylpropyl ketone, I drew my carbon double bond O, then I drew the methyl on the left, and I drew the propyl on the right. The IUPAC name of this, by the way, would be 2-pentanone. All right, next example says, what's the proper IUPAC name? That means not a common name, but the official name using all of our naming rules. What's the proper IUPAC name of each? So A, CH3, CH2, C double bond O, CH2, CH3. This is 3-hexanone, all right? Common name, by the way, would have been diethylketone. If you go look at it, you see 2 ethyls coming off the ketone. All right, B. I put quotes around it because this is the common name, dipropyl ketone. So we draw our ketone, C double bond O, and then we have a propyl group on the left of it, propyl group on the right of it. And if you look closely and then rename it with the IUPAC rules, the ketone's off of carbon 4, and it's 7 carbons long, which is hept. This is 4-heptanone. All right? All right, new topic. Double lines there, new topic. It's still aldehydes and ketones, but now we're going to talk about some of the properties. Solubility, boiling point, stuff like that. So C double bond O, as you remember, is the carbonyl group, and it's polar. It's polarized in the direction of oxygen. Oxygen's more electron withdrawing, right? So the polarity of the carbonyl group makes these guys polar. A lot like alcohols, though. The longer the carbon-carbon and carbon-hydrogen, or the carbon-carbon chain, the less soluble it is in water. So let's reread this. Polarity of the carbonyl group makes them polar. So their boiling points are higher than a similar nonpolar alkane. So why are the boiling points higher if I'm polar? Well, I'm drawing 3 little representative molecules with the polarized delta plus and delta minuses, and a plus minus attracts, right? So you see how those double-headed arrows, those are attractions between molecules. If you're going to boil something, you got to break those attractions, right? You got to crank up the heat, in other words, the higher boiling point. So the first property is that the polarity makes aldehydes and ketones higher boiling points than their complementary or to their corresponding alkanes. Number 2, longer the R chain, that's the carbon-carbon chain. So if you have a bunch of CCs and CHs, this is going to make it nonpolar overall. So longer the R chain, the higher the boiling point, and the lower the solubility in water. So the first one I've drawn there is 4-butanal. I'm sorry, it's just butanal. The second one here is ethanol. So ethanol has less carbons, it's more soluble in water, and its boiling point is higher. Example, CH3, CH3, CH2, C double bond O, CH3. This is a ketone. These are both ketones because the carbon with the double bond O is attached to carbons. C double bond O is attached to 2 carbons. All right, so a boiling point of 102 versus 56. All right, the smaller one is more soluble in water, and its boiling point is actually lower because it is smaller and it's more polar overall, and therefore it has stronger intermolecular attractions. All right, now the reactions are always what I think are the more important thing to know. Reactions of alkenes, reactions of alcohols, now reactions of aldehydes and ketones. So reactions of aldehydes and ketones, they will be oxidation and they will be reduction. So the oxidation is the first one, oxidation of aldehydes. By the way, ketones do not get oxidized. They would be NR. Oxidation of aldehydes, here I have an aldehyde getting oxidized to a carboxylic acid, corresponding carboxylic acid. You just change the H that's attached and turn it into an OH, if you will. So using that as an example, or using that as kind of our answer key, let's do the next example. Draw the products after oxidation occurs. So I have to look at this and find out, is it an aldehyde? If so, I can do an oxidation. Is it a ketone? If so, I cannot oxidize a ketone. So A, CH3. See, let's find the, if you see the C double bond O in A, it's attached to an H, right? This is an aldehyde. We will change that H to an OH. So for A, you basically rewrite everything until you get to the functional group all the way on the far right, the C double bond O, and you leave the C double bond O because it's part of an aldehyde and the carboxylic acid, and then you make the carboxylic acid product. 2,2-dimethylpentanal is not helpful. I have to draw out the whole structure. I just drew the bare bones, and now I have to fill it in properly and convert that C double bond OH to a C double bond OH. So in both of those examples, aldehydes were converted by oxidation to carboxylic acids. Now C, if those two were aldehydes, this is probably a ketone. I can tell right away from the "-one" ending, it's a ketone. And if I know that ketones don't get oxidized, I can just write NR. But just to show you, I'll draw it out. We have a 2-methyl, and then we have a 3-pentanone. So I've just drawn the bare bones. I recognize now, maybe a little easier, that it's a ketone. And then I say, oh, well, ketones are not oxidized. So no reaction, NR. So that was oxidation of aldehydes, and ketones don't get oxidized. So now we have reduction of aldehydes and ketones, and both of these guys can be reduced. What do they get reduced to? They get reduced to alcohols. All right, so reduction of aldehydes and ketones. So I just have a standard carbonyl carbon there with 2 unannounced attachments, and then the reduction is going to occur, and it's kind of the reverse. Well, I don't want to say the reverse. We'll leave that alone. But if I reduce it, it goes left to right and makes an alcohol. If you were to oxidize it, it goes right to left to form the carbonyl group. So essentially what you're doing when you do a reduction is you're adding H2 across the C double bond O double bond. So when you rewrite your notes, put a big star by this or highlight this. You're adding H2 across the C double bond O double bond when you do a reduction of an aldehyde or a ketone. So let's use all that we just saw and what we have in our notes there to help us with this example. First example says, draw products of the following reduction reactions. So they're telling us they're reduction reactions. Take note of the reagents. Those reagents should help you recognize, oh, H2 with platinum as a catalyst. This is a reduction. I convert that aldehyde to the corresponding alcohol. And just as an FYI, I've drawn out what that little CHO looks like on the end. It's a C double bond O with an H. All right. So that was an example of a reduction. Here's another example. M, you remember M? Right, this is meta. This is 1,3 substitution. But at any rate, we are going to reduce the aldehyde here to a alcohol. In C, cyclopentanone, that's a ketone. And again, the reagents are H2. By the way, the PT and the Ni you will never see written into the product. PT and Ni are never a part of any product in this class. PT and Ni are catalysts. So M-chlorobenzaldehyde, I've drawn it out for you there. And if you're going to reduce it, you will not interfere with the aromatic compound. The aromatic compound is very unreactive. The aldehyde turns into an alcohol. Now for cyclopentanone, the double bond O turns into an OH. Okay. We've also got an extra H on the vertex there. That's part of the cyclo of the ring, but it's understood. It's not drawn. So next example. What ketones or aldehydes could be reduced to get the following alcohols? So now we're going to draw the products, and we're kind of working in reverse here. What ketones or aldehydes could be reduced to get the following alcohols? Well, let's find the alcohol group. Let's find the hydroxyl. Let's find the OH. And we just convert the OH into a C double bond O, all right? Bearing in mind carbon has to have octet rule. So if I'm reducing to get this alcohol on the six-membered ring here in A, you can draw everything else on the left, and then you can draw the ring, and then you recognize, okay, well, there is my vertex right there. That I need to put a double bond O right there, and I get the corresponding ketone. For B, I located the OH, I located the carbon the OH was on, and I turn it into an aldehyde. Why an aldehyde and not a ketone? Well, if the OH is on the very, very end, it's going to be an aldehyde. If the OH is kind of in the middle of something or not at the terminus of a chain, it's going to be a ketone. All right? So Chapter 11 and Chapter 12 are done. They're very difficult chapters. Please write all your notes out for the 6 videos you've had since exam number 2. Since exam number 2, we've had 6 videos already, so please watch them, rewrite your notes, and get ready for quiz number 7. All right, see you soon.